Dear students and the participants of the course on railway engineering, today we are going to discuss about the rail weirs. If you remember, in the last lecture, we discussed about the rail failures, the few of the types which were left, and then we talked about the metallurgical investigations which are required to be done under certain specific conditions only. Not all or each every rail failure has to be sent for that particular type of an investigation. Then after that we did talk about that what are the actions to be taken if there is a rail failure occurring, or if we found that there is a possibility, what are the precautions which can be taken. Now after completing these rail failure part, we started with the weirs. We discussed about the what type of weir can be there, and then we talked about the reasons which can be attributed to different type of weir. Today we are going to discuss about those types in more detail, and then we will be taking up the measurement of the rail weir, and finally what can the actions which can be taken up so as to reduce the rail wear. So let us start with the classification now. Now the wear and tear, this happens due to different reasons which we have already talked about. We talked about the various loads which can come at the top of the rail head. We talked about the conditions in terms of the curves or the sharp curves where there is a lateral movement of the wheels and the flanges hit at the side of the rail head, or there may be more rubbing action at the top of the rail head, or it can be due to the acceleration, deceleration or the braking conditions. So it can also happen due to the tracks which are passing through the coastal areas, in the deserts or in the tunnels. So there are different environmental, track related or load related aspects which are there, due to which those wear and tear they are occurring in the rail sections, and they will be occurring in the lateral and the vertical planes of the rail head. So you will find that in the case of a rail head, which of course in the previous lecture also when we were discussing, so there is a possibility that something may happen here, or some wear may take place at this location or at the central part where these two sides, that is the upper side or the tabletop and the side of the rail head, they are meeting together. Now when this wear or tear takes place and there is a possibility of some material which has gone out, so there can be a new profile which may come in this way, and when this type of a profile happens, there will be a loss of weight of the rail section. Now there is a permissible value, up to permissible value. If it is happening, it is fine, but if it is going beyond that, then it will adversely affect the strength parameters. So with respect to the loads which are coming from the top, which are being registered by the strength of this rail section, that strength can also be talked as a UTS, that is the ultimate tensile strength or the yield strength. And these are few of the points which we have discussed previously also. When we talked about the flow of the material, we talked about the flaking or the shelling of the rail head. In all of those cases, this was discussed. Now if the loss is heavy, then what will happen, because the total area, sectional area which is required to take up those loads, now this is reduced. Now if this is reduced, it means there is going to be heavy concentration of the stresses, and when there is a heavy concentration of the stresses with respect to the strength parameters, yield strength or the ultimate tensile strength of this rail head section or overall section of the rail, there will be a problem, and this type of a system or this type of a rail needs to be taken out. So in those cases, a stage will come where the affected rail needs removal or renewal. You may renew the rail or you have to completely remove the rail section. It all depends on what is the amount of that wear and tear which has happened at any of the location. Now, based on the location where the rail is placed on the track, this classification can also be there. We did talk about that based on location it can be say the starting condition, accelerating condition, deaccelerating condition, braking conditions, or this can be on gradients, it can be on curves. So, all of those type of locational aspects will fall into the first category. Whereas, the second category talks about the position of wear on the rail, and this position of wear on the rail can be on the top of the rail head, on the side of the rail head, or at the ends of the rail head. So, that means when we are talking about a rail head here in this form, so on this particular rail head, if we extend it and say goes into the form of a foot also. So, there is a possibility that it may happen here, or it may happen on this side or on this side. So, this is the top of the rail head. This is the side of rail head, and this is the rail end. So, any of these locations positions can be there. So, first of all the top of the rail head, that is being defined as 1, the side of the rail head being defined as 2 in the diagram being created, and the third is the ends of the rail, that means we are talking about this particular location. So, these are the various things which we are going to cover one by one, and we are going to look at what can be the possible reasons due to which the wear either at the 1, 2 or 3 location on that rail may occur. So, starting with the location of the track, the very first one which we are discussing is the sharp curve. So, there can be a curve where the radius is very large. So, if we talk about the radius, then that is the radius R1, but there is another case where a sharp curve is being provided. So, with respect to the center line profile, if we say that this is R2 which is less than R1. So, what is going to happen in those sharp curves? Of course, in both of the cases there is the centrifugal force which is acting, and this centrifugal force is acting in the outward directions with respect to the center of the track or the rotational position. That means, if this is a pivot point with respect to that, if we are looking at. Now, when this particular condition happens and there is a centrifugal force which is exerted here, then high lateral thrust it will get exerted on the outer rail. So, if a train is moving here in this form with the bogie and the wheel arrangement, wheel axle arrangements being shown, in this case it can be like this. So, here a thrust is going to be induced on the outer side. So, this is an outer side or this is outer side here. So, more thrust is going to happen when that is moving in this direction. So, the higher thrust gets exerted on the outer rail, and when there is a higher thrust, it means the whole of this wheel and axle assembly that will move towards the outer side. So, in terms of the rail, if we say that if it is moving towards the outer side and we assume that this rail is basically on the curve and this is the outer rail as being written here. So, there is going to a wheel which will be moving so this is a wheel and flange arrangement. Because that is the gauge side. So, higher interaction will start occurring in this portion, and this higher interaction between the wheel flange and the inner side of the rail head. Now, if this happens, that means it is not only just striking, but also there is a rubbing. So, these two actions will simultaneously start occurring at this particular location. And when that happens, then this gauge face of the rail, this is going to be deteriorated. There will be more stresses in this particular area, and slowly you will find that the shape has changed. There is either a loss of the material at that, or some deformation has occurred at that particular location. It may also happen that some shelling of the material may also be there, which we discussed previously. Now, similarly, if we talk about another condition, which is approach to stations. Now, in the case of approach to stations, when the train is approaching a station, that means it is in the deacceleration phase, and then finally the brakes will be applied and the train will be stopped at a designated location. There is a specific point up to which the locomotive will go and it will stop there. So, in this deacceleration phase, when continuously the brakes are being applied, so there will be an issue with respect to that particular track, because when the brakes are applied, there are more forces which are being put where they are going to put at the top. So, there are more stress on top due to brakes. So, this is one case. Another case is now the train has stopped at the platform and now it is going to start back. So, there will be acceleration phase of the departing train. When there is an acceleration phase, it means now with respect to the rail and this wheel combination, which we have discussed previously also, it has to move forward. Then it will try to exert some force at the back side, so that it can push in the forward direction. So, in that case also there will be more stress on the top of the rail head. So, this is also another issue. So, you have the departing trains causing higher pressure on the surface of the rails, that surface which we are saying here is a top table. Then the third case is the steep gradients. Now, in the case of steep gradients, what will happen? We are moving on a track. In this case, if say you are going upwards, or there can be another case where the train is coming downwards. So, in both of these cases, the conditions are going to be different. Now, when we talk about an upward movement, there is more horsepower or the hauling power will be required, and it will try to keep pushing on the rail head, so that it gets a push in the forward direction. So, this is one problem here. Now, another problem in the case when you are talking about a movement in the downward direction on a steep gradient, which is being defined by an angle theta here. So, the problem is with respect to the speed, there is a gain. So, whatever weight is acting here in the downward direction, it will have a component here as well as component here, and this component which comes here, this creates momentum, and we have to control the speed. That means again there will be application of brakes, and this application of brakes will be like again this, so that the train reduces its speeds while coming on this steep gradient. So, there is a problem of the application of brakes so as to control the speed. Now, when these tricks are happening, either you are going up or you are going down, there is a constant rubbing on the surface of the rail head. So, in this case at the top there will be a constant rubbing, and when this constant rubbing is there, and because you are talking about gauge face and the wheel is being aligned in this form, So, this constant rubbing, because now what we have done is we have also given a tilt to the rail as 1 in 20. So, this section will keep getting rubbed, and the same happens at the wheel location of wagons. In the last lecture also I did talk about it, wherein I said in the case of Nilgiri's railways, where we are going to Uttarakhand, there even in the case of wagons also the brakes have been provided, because there are so much steep gradients which are provided in that particular area on that track. You have to control the speed, and while applying all of those brakes, finally what happens is that all of the assemblies get heated, and therefore the train has to be stopped at one location, and a cooling period of 10 minutes is given at that location, at that particular station, and after that only the train starts back for the further journey. Now, when this higher application of brakes is there, it may result in the head burning also. We have seen that what type of a head burning type of features can be there. So, if you are talking about this as a rail head, we have seen that the burning points were occurring at different locations. So, some darker patches or the lighter patches were shown in that photograph. Another case can be the weak foundations. Now, in the case of weak foundations, the movement of heavy loads on the rails which are supported by the weak foundations would cause heavy or higher stresses on the rail head, because now the foundation is not being able to sustain the loads. So, everything which is coming at the top of the rail is finally supposed to get transferred to the bottom section. Bottom section here means we are talking about the sleeper, and which is being embedded in the ballast cushion, and finally it goes to the formation level. So, if everything is weak in this area, then the main component which is left, which can take the load, is the rail section, and therefore the higher stresses are going to be induced at this point, and therefore you will find that there is possibility of wear in this case also. Then the another type of a location can be tunnels or the coastal areas. Now, one unique feature which is common in both of these is the presence of moisture or humidity. So, in the coastal area also, because of the proximity to the sea, you will find there is more moisture in the air, and in the case of tunnel, whatever moisture has come in that because of a subsurface infiltration of water, that moisture will remain there if the tunnel size is big. If it is a very small tunnel, then probably that type of a problem may not come. Now, this moisture or humidity, this is also going to become a contributing factor, and this contribution is coming in terms of one type of a failure or one type of a problem in the rails which we have discussed previously, that was corrosion of the rails. And if this corrosion of the rails, if it starts penetrating, where we talked about that what should be the depth of penetration or extent of corrosion which can happen on the rail, this finally may cause the wear of the rail section, and there may be particles which may come out of the rail section. Now, another contributing factor is the availability of sand, and this availability of sand is related more to the coastal areas, as well as it can also be applicable to the desert areas. In both of these cases, if the sand is available, and we discussed about that, if wind blows, the sand is going, those particles, they are very small particles, they will get here in terms of a form of a coating will be there. So, if this sand coating happens and there is an interaction of the rail and the wheel, then in that case this sand coating will induce abrasion action, and if this abrading action is there at the top surface, you will find slowly and slowly there will be a change in the profile, there will be change in the material sectional area of this rail head, and there will be loss in the weight of this section. And as soon as that happens, it will not be able to sustain the loads which are coming. You will find that they are going beyond the permissible limits or the strength parameters which are there, and finally the wear will start happening at a faster rate. Now, this abrasion occurs due to the presence of sand and interaction of the wheel flanges with rail heads. That is what I just defined to you. Now, let us move with respect to the rail. So, a specific position on rail. So far we talked about where the track is available and based on that particular location how the problems are surfacing. Now, on the top of the rail head, this is the first case which we have defined when I have made one diagram while defining the various locations. So, on top of the rail head there is a higher concentration of stresses due to the high moving loads, and this high moving loads they will be coming repeatedly. It is not that once in a while in a month or a year that heavy load has come. Now, continuously the loads are increasing on our network on Indian Railways. I have shown you in the very starting when we started discussing about this particular course that there are certain routes which are defined in terms of high density routes or highly utilized routes. So, there the loads as they are increasing and it's going say beyond 20 tons and more, then the high concentration of stresses will be there, and this higher concentration of stresses will get augmented if the train moves at a higher speed. We discussed about this particular augmentation, and this augmentation is defined as the speed factor. I have been talking about this whenever the speed effect is being discussed in our lectures. So, this augmentation because of the higher speeds, so whatever loads are coming, so those loads which are static in nature will transform into dynamic loads and will cause higher impact. Another thing is that there is a problem with respect to the rail temperature. That this rail temperature may get increased because of the moving loads which are of higher values. It can also happen because of the air temperature of the surrounding environment. So, any of the cases can be there. So, because of that also there will be thermal stresses. And because of these thermal stresses, when the movements are there and the movements have been restricted by way of the fastenings and fittings, then also the effect may come towards the head because now those stresses are getting created there. Now, repeated nature of such conditions may result in the flow of metal from the surface of the rail head. You can see that there is something being shown here which is basically caused due to a location where the locomotive is stopping, and the higher pressure which is being exerted by the locomotive so as to remove the inertial effect and start the train into moving condition, these burns can also be observed at the top of the rail head. So, this type of a system may be there, and at the same time when the temperature has gone up and when there are high loads which are coming at the top. So, there are 2-3 things which are happening together. There is a high load, there is a high temperature, and because of that the deformation may start occurring here. So, the plastic condition may occur, and because of that plastic condition finally if the loads are higher then the material will start flowing towards the side, and you will find that there is some material which has come at the top of the side of the rail head. Again, if you remember, this is one aspect which we discussed, and if this happens and it comes on the side of the rail head, then it tightens the gauge, because now the space which is left as 1676 mm will reduce in that form here because of that. But it shall be within the permissible limits of the clearances which are there with respect to the wheel flange. So, it is not that the wheel flange is always touching the rail head. So, rail head is somewhere going here. So, this is a clearance which is available. So, if it is happening a bit it is okay, but otherwise this tightening of the gauge will also create a problem, and in that case if it happens that will be creating an issue with respect to the more stresses on the site, and the wear may start occurring there also. So, at the moment we were talking about the top of the railhead, but because this is a correlated aspects, then that is why I have discussed that in association with this aspect. Now, the humid conditions which are persisting for a longer time period, they may cause corrosion of the railhead, the surface as well as the sides. So, any of this area, that is 1, 2, 3, any of these area, they can get corroded because of those humid conditions, and in that humid conditions, if that is associated with the say acid fumes, then this is further deteriorating aspect. Then the presence of abrasive charge like sand in the coastal areas or deserts, it will also cause the wear on the railhead during the rail wheel interaction. So, this we discussed previously itself. Here we talked about that there is a sand coating, and due to sand coating there is going to be an abrasive condition, because now the wheel which is moving at the top of the railhead, in between those two there will be sand particles. So, as soon as those sand particles are pressed, they will create abrasing action on the railhead. The movement of trains at the high speed and the application of the sudden brakes, that may cause a skidding of the wheels on the railhead surface. And when this skidding happens, then this means there is a continuous rubbing action which is happening on the surface of the railhead. The train is continuously moving in this direction. So, it is a longitudinal direction. So, you will find that the rubbing action is continuously going on the top of the railhead. Because of this skidding condition, the train may not stop exactly as soon as the brakes are applied. There will be always some distance which is being travelled, and that distance will be based on the speed of the train at which the brakes were applied. In case of the steep gradients, the consistent application of brakes, consistent application, the reason being, as I told you previously, when you are coming down and the speeds are increasing, you have to control the speed of the train. Otherwise, it will be difficult, very difficult to stop the train at the next station, or to negotiate the curves, or to negotiate those particular gradients. So, a consistent application of brakes is there, and this consistent application of brakes is not only at the locomotive, it is also at the wagon level. So, it increases the temperature which results in the burning of the railhead. Continuous application, you are applying again and again the brakes because you are going down. So, you are trying to stop. So, if you are trying to stop the train in this form, so continuous application on all of these points, first of all by locomotive, then a wagon 1, then a wagon 2, then a wagon 3, this is happening. So, this rail temperature at this location will be very high, and as soon as it happens, the burning will be there. Then improper design of the track. Now, improper design of the track at the curved location or stretches in terms of inadequate super elevation. If it is inadequate super elevation, because you need to talk about a track in this form. So, this is a bit higher on the outer side as compared to inner side. So, if this value of h, which may be the amount of super elevation which is to be provided, if it is less or it is more, in both of the cases it will create the problem. If it is less, then there is more movement of the train outwards for a less condition, and if it is more, then the train will remain in the inward condition. So, the wheel and axle assembly, that will remain in the inward condition if your super elevation is high. And in that case, here there will be more stresses, where in the other case the stresses are going to be more at this location. So, there will be a higher rubbing of the wheel with the head of the rail as well as the sides of the rail head. So, both of these things are going to be impacted. Another condition can be the slipping of the wheels on the curved sections. You are having more movement of the wheels as compared to the distance which is being travelled. So, it can happen on the curved section as well as it can also happen on the steep gradients, and this will also affect the top head. We have already discussed why this is going to be there. Then fluctuations in the track. The compaction is not good, the ballast cover which is being provided is not being compacted in the right manner. There are fluctuations which are coming because of the weak foundations here, the formation level. So, in all of those cases, if anything happens, or even in the case of the track which should be straight, instead of straight it has got some sort of kink condition which we discuss as a buckling of the track. So, either it is in the alignment or it is due to the settlement of the track. Again the stresses are going to be induced more, and when they are more, then there is a higher wheel and rail head interaction which will result in the faster wear. Then the rail heads are given a slope of 1 in 20 so that the interaction of the wheel is proper, but the sleepers when they are given the edging, that is a seat is being provided with the sleeper where 1 in 20 slope is provided. So, in that case again the wear is going to increase. Now, it increases with the higher traffic density, especially on the suburban rail sections. When we talk about suburban rail sections, it means in Mumbai, in Kolkata or in Chennai. In all of those locations we have suburban trains. So, there is a higher traffic density, continuous movement of trains is there every 3 minutes, every 6 minutes, 8 minutes, 10 minutes there is a train moving on the track, and that too many of the times they are full, completely loaded. So, that load which is coming will also increase the wear. Then high impacts are observed due to the rigidity of the wheelbase and the lateral movement of the axles, and this is happening basically on the side of the rail head. So, this side of the rail head, if we are talking here, specific this particular condition may be there when you are on a normal track which is a straight track, but there is a lateral movement because of the track irregularities. So, the train axle wheel axle combination that can move in either of direction, and otherwise in the case of the curved section we have discussed this type of things. Then when there is a slipping or skidding of the wheel on the rail due to the curved sections, then the higher impacts are going to be on the sides of the rail. It can be inner rail, it can be outer rail, it all depends on again which particular axle wheel combination we are talking, front or the rear, and what is the radius of that curve, as well as what is the speed at which the train is moving. All of these combinations will define where this impact will be more. So, we talked about here the speed, the radius, these are the two aspects which will be more important in this way. Then flattening of the rail is an indication of the overloading on the inner rail. If slowly and slowly instead of curved section it starts flattened out, then that means there is a problem here, it is happening here. Then slipping of wheels, its sets occur due to the higher contact stresses caused by heavy axle loads which we have discussed previously. Another thing which can happen is there is a possibility of unsprung masses, or when the train is moving at a speed which is less than the equilibrium speed. When we say equilibrium speed, it is correlated with the super elevation. So, on a curved track where the super elevation related speed is not there, then what will happen? Then the whole of the assembly will be shifting towards the inner side. So, I talked about this particular aspect. So, this particular assembly, so more stresses will be here, that means the gauge face is going to be impacted more. In case of the speeds which are lower than the equilibrium speeds, the wheelbase remains on the inner side and rubs on the inner side of the inner rail. So, that is what is being defined. Then outer rail of a curve withstands heavy pressure from the wheel which results in the running edge becoming worn out, or it is also defined as a side cut. The wear on the gauge face is especially pronounced in the case of suburban rail sections where the rolling stocks are provided with laterally unsprung traction motors. EMUs are there, and in those particular case if unsprung traction motors are usually used, then that is a condition where along with the speed and the amount of load which is coming, this will happen. So, you can see that there is a impact here in the case of wear at the specific positions on rail. So, the conditions are shown here. There is some material which has even gone out. So, the shelling has happened. So, one is the flaking, means the flake, a small flakes have gone out here. Shelling means a big amount of chunk of material has come out. The next type of a wear with respect to the specific position on rail is on the end of the rail. Again, when we were talking about the various rail fractures, we have discussed about it. We talked about the battering, we talked about the hogging. So, the similar thing has been shown in this diagram. So, very first thing is wide joint opening. So, this gap which is being provided between the two rails, if it is more than the prescribed value, a standard value or the permissible value, then what is going to happen? In this case, there is higher striking by the moving wheel. So, whatever this wheel is coming, because this gap is more, then there is always a possibility that it will strike here and it will cause the battering of the rail end. So, this is one reason. Another reason along with this which will cause this type of a battering is the diameter of wheel. If the diameter of wheel is small, then also this contact which will be there, if I draw here, so then if it is a small diameter wheel, so more contact will be here and therefore more pressure will be exerted on this rail. So, that will also be a problem. This cannot be an additional factor which you can remember. Now, difference in the rail surface level at joint. So, you have a rail here, one rail is provided in this form, another rail is going in this. So, there is a level difference. If there is a level difference, then again this is an issue. Now, one thing which can happen is because of the weak formations at the bottom, and another can be that because of the load which is coming, say in this case, if we assume the load is coming here, there is a wheel here and this is putting the pressure and this is a weak formation, then the level has gone down, and when this wheel comes in the forward direction, say we assuming in this case that the train is moving in the left side direction. So, there will be this gap, because of this gap the train will hit hard on this particular location. So, the end of the rail it was going to be hit hard and there will be a sort of a wheel jump here. So, this is also a problem. So, it occurs due to the bad formation or the loose packing of the ballast, or it will cause a striking by the moving wheels. One factor which we have been discussing from the very starting is the poor maintenance. The poor maintenance of the track in terms of the formation level, in terms of the ballast, in terms of the sleeper, in terms of the fastenings between the rail and the sleeper, or even in the case of the rail which has been observed to have some of the fractures starting and the remedial measures has not been taken in those cases, then it is always a possibility that because of that poor maintenance these type of things may occur fast. Now, let us look at the measurement of the rail wear. How the measurements can be done? Very first thing is we talked about there is a loss of some material from the rail head. If there is a loss of material, then one easiest thing which can be done is to take the weight of the rail, and that will give you an idea that whether there is a wear or not. And we talk about this taking the weight of the rail, there is a permissible limit, usually 2% is the limit. So, this is the permissible value, and maybe we will be looking at these permissible value afterwards also. Another is the profiling of the rail section. There are different ways in which the profiling can be done. One is with the help of lead strips, another is with the help of needles, or the third can be the special instruments which are designed to measure the profile. You can see on the right hand side one photograph is being shown. It is a profilometer here, and this is a digital profilometer where the digital recording of the values is continuously going on. So, we can keep it putting at every different locations. It can even move with the help of the rollers being provided, that can also be a possibility. So, as number of locations the measurements have been taken, that will give you an idea whether there is a wear at any of the section. Now, when we take this number of measurements, it says that if it is a wing rail, then the measurement is done at 10 different locations, and if it is a tongue rail, then it is done at 7 different locations. Of course, this wing rail and tongue rail we will be discussing when we will go to the points and crossings and the turnouts. So, there you may get further clarity on this aspect. Then when we are discussing in this form, we are taking the measurements in this form, that the measurement starts at the toe and they are done at every 100 mm away towards the heel side and up to 600 mm from the toe. So, this is how the measurements will be done. Now, on the right hand side again, one photograph is being shown. So, you can see that there are different needles or calipers type of items which have been used, and again they are being fixed at the top of the rail head, and then the values at the head, at the side, all of those can be taken simultaneously. So, that is where the calipers can also be used, or we can just plot the profile by using some advanced techniques. The lateral wear is measured at 13 to 15 mm below the rail top table. So, whatever is the rail top table is here. So, at a distance of 13 to 15 mm we take the measurement, because this is a curved section. So, we have to take a measurement at that point where it starts strengthening. Another issue is that how to prevent these things, what actions can be taken. So, very first is the lubricating the gauge face, but we are not lubricating the head of the rail. It is the gauge face, means whatever the material is being provided. If you see here, there is a fish plate with the bolts, and the greasings of the fish plates and the bolts is being done here manually. There are automatic lubricating items also, and they can be fixed and they will lubricate these locations. Now, turning the rails when the side wear reaches the permissible limit. So, you have the rail sections like this. So, this is a say a section in this form. Now, there is a wear here. What we do is you just simply turn it in this one 180 degree. So, the weird section will go out. So, this is a weird section, and then a better section will be on the inner side. But then if this is being done, it can be done only by matching the faces or the ends of the rails, because it is being connected with another rail. So, that is important aspect, should be taken care of. Welding of rails, if the wear is not excessive, within the permissible limits, near the permissible limits, it is fine, but if it is more than that and the welding is not possible, then we have to replace the affected area. And such specific conditions which has occurred, which we have discussed previously, was related with the battered rails or the hogged rails, where we have gone for a dehogging and we have even cropped the sections for a length of around 6 meters and replaced by another new rail section, and then the welding has been done and the joining has been done. Then wire brushing to remove the rust and the dust is another thing. Another way is to remove the kinks in the rails, which may happen because of the buckling. So, jim crowing is being done. So, on the right hand side, the jim crowing is being shown. So, on the rail section, you can see that there is an equipment along with this bar. So, we are trying to put the rail back to its normal alignment. Here, there is a way out by which the screws are being taken out using the normal manual way of mechanism, and then again the repair is to be done at that location. So, these are some of the actions which can be taken when the wears are there. So, we stop with this. What we have discussed today is the wear in rails, their classification, and the wear which may occur at a different locations along the track, or it may occur on different locations on the rail. That can be head surface, that can be on the side, or that can be on the end of the rail. And then what are the ways in which it can be measured, and finally how it can be controlled. So, what actions can be taken for that? With this we stop here. Thank you. We will be meeting in the next lecture.